Okay. So that's the wrong week. Today is week 5 of Sage Crime and Forensics, and we're going to be going over chromatography. And after that, we're going to do like a simulation, like a lab, basically. And we're going to do some evidence synthesis and have you guys work on your course project because I want to give you as much time as possible to work on that during class. Yes, see me?
I think last time you said we needed to bring something. What did we need to bring?
I'll go over that before we do the lab again, but you'll need like a tall water glass with like a little bit of water. Just get a tall water glass. You'll need a pencil. Not sure where mine went from earlier today.
Mechanical or non-mechanical?
It doesn't really matter, it just has to be about this thin. And then you'll need tape and colored pens or pencils. Colored pens or markers, preferably black, like a Sharpie. Sharpies work really well for this. Yeah. Probably not a dry erase marker. You
Can I
want
go
something.
get some stuff?
Not now. We're gonna do a mini lessons first, and then I'll give you guys some time to get your things. Okay. We're going to do a little bit more chemistry today, less on the technical side and more of general terms. And we're going to learn about chromatography. So element, compound, mixture. All matter can be classified as an element, compound, homogeneous mixture, or heterogeneous mixture. So last time we said that everything is made out of matter. The air, the computer, pens, paper, you yourself are made out of matter, and matter is made out of atoms. And matter, I'm sure you guys have heard about like the states of matter, like solid, liquid, gas. However, as you go further into your science journey, you're going to be classifying matter in a different way. Because when you think about it, matter, it's the state of matter that something is very like not like solid is the best way I can describe it. Like, because the state of matter depends on what temperature the matter is. So the most basic example is like water. Water at room temperature is a liquid, but you can freeze it when it's below 0 Celsius, I believe, into ice, a solid, or it'll boil into water vapor when it is above the boiling point. So based on the temperature of the matter, the state of the matter changes. However, with element, compound, a mixture, that doesn't change with temperature. It stays the same throughout. So I think we went over this last time, but an element, it just means that all of the atoms have the same number of protons. So they're the same element. For example, gold, it'll still be gold whether it's liquid gold or solid gold. And it's still one element. So that's why I said that these classifications don't depend on temperature. And with the compound, it's just atoms bonded together. So you have to have an actual bond between the atoms for something to be called a compound. For example, water is H2O, and it's still going to be H2O even if you freeze it, even if it's in the air, or even if it's liquid. So it'll always be a compound unless you somehow break those bonds. And the last two are mixtures. So mixtures are compounds and elements that are mixed together, but they're not bonded with each other. So you might think of this like let's say I have this like block of something, and I have these purple dots that represent like let's say one element, or we can use the air. Like the purple dots are like the nitrogen in the air, because air is mostly nitrogen, and nitrogen is an element. So there's just one dot since it's just an element. And let's say like there's blue dots too. There's blue dots too, but they're not bonded together. They're just kind of scattered all around. So it kind of looks like this. And let's say the blue dots are like oxygen or something. And there's less oxygen than nitrogen, but none of them are bonded together. If I wanted to draw, for example, like a compound, I'll make a bigger box. I would put hydrogen and oxygen. So let's make hydrogen like pinkish. I'd put a hydrogen, kind of a circle like shape. So there's hydrogens. So this would be like water, and oxygen is blue. So H2O, one hydrogen, two oxygens, and it looks something like this, like a Mickey Mouse kind of. And you see how they're all bonded together, like they're touching, and the atoms are bonded to each other. So that would be a compound rather than this. Air would be a mixture of different things. And a homogeneous mixture is just one where everything is spread out evenly. You can't really tell the difference between the different parts. And a heterogeneous mixture is one where they're not spread out evenly. So for example, like an orange juice with like pulp, that would be a heterogeneous mixture because there's a difference between the juice and the pulp, and you can kind of see that. They're like chunks of pulp. All right. So now we're going to move on to chromatography. So what is chromatography? Essentially, it's the separation of the mixtures that we talked about. So mixtures can be separated through chromatography. And the most common way, or the most like real life situation, kind of forensic way that will be using chromatography is to separate pigments. And that was the way it was used in the very beginning. So pigments are a mixture of different colors. Yes, Ming?
I think I did something like this where we would draw like a dot with marker and then we would put it into water and then like it would do that.
Yeah, so that's chromatography. That's called paper chromatography. So pigments are homogeneous mixtures of various different other colors, especially black. Black, you'll never really find a completely black pigment. Yeah, Nora?
Wait, so it's like separating the mixtures. I remember once at some point in elementary school, we like took Skittles and separated the color from the white. Is that kind of like it?
Could you say that again? You separated what from what?
We separated like the dye from the base of the Skittles in elementary school. Is it kind of like that?
Yeah, that's basically what this is. So the dye in the Skittles is like a mixture of different like pigmentations, and that's what creates that color of the Skittles. And Ming, do you have a question? Oh, okay. All right.
I think one of my favorite ones was black because like I really like the colors.
Yeah, so black pigments. Most pigmentations are made like in nature. So all the natural pigments are mixed together to form a pigment. And black, completely black pigment is virtually like, it virtually does not exist in nature. You have to mix a bunch of different things to get black. So that's why black is a really interesting color to do chromatography with. Mm-hmm.
And can I use more than one color?
Yes, but only if you can like, only if your glass is wide enough to fit all of them.
Okay.
Yeah. Um, so
So what do we need right now?
I'm going to tell you the materials later, but we're going, because I want to get through this mini lesson first. But yeah, so the way chromatography works is that the mixture is dissolved into a mobile phase, basically water in this case, and that carries it through the stationary phase, which would be the paper. And because different components and different compounds travel at different speeds through the stationary phase, that's how we get these beautiful colors. You see there's like pink here and there's blue at the top, and that would make, I think that's purple. And the orange, you can see a little bit of like yellow at the end. And for this one, you can see it less clearly. I did this a couple days ago, so it's kind of weird. But at the top, it's much more light and orange. And at the bottom, I don't know if you can tell, it's a little bit more purplish.
What color did you use for that?
I used one of my Tombow markers. It was like this red color, I think. Let me see. Yeah, it looked like this in the original. This is what the actual color looks like. And it's kind of like a highlighter pink. And it's really interesting to see how these different pigments are mixing together. So that's why I want to do this. And it's really good to tell between different pens because each different pen company uses its own formula for their ink mixtures. So I'm going to demonstrate first.
Also, there's like a little blue line.
Yeah, I know. That's just an annotation.
Okay.
Okay, so I'm going to demonstrate first so you guys know how to do it, and then I will set you guys free to do the lab. But so I'm not going to give the full list of materials now because I don't want you guys to go off and miss this because I want you guys to know the correct safety procedures. This isn't like the graphite thing. It's kind of like the graphite thing, but probably more severe. So I said you wanted to get a glass, preferably not a drinking glass. However, if you're going to use a drinking glass like this, after the lab, you must wash it with hot water and soap or dishwashing thing, because there might be a little bit of ink in there. So please do that. With hand washing today, it won't be, yeah, Nora?
Oh yeah, so I'm using like I don't know, I found this somewhere. I found like this. Is this okay?
I think that's pretty good, yeah. If you're not gonna drink from it, it should be fine. Just make sure you're like washing it out. But if you're going to use like a drinking glass that you're going to drink from later, or somebody else is going to drink from, please wash it out with soap. Most inks now are non-toxic, but just to be safe, please wash them afterwards. With hand washing, I'm not going to be as strict, but if you do get pigment on your hand, please wash it off. And again, like not really goggles or aprons. If you want to tie your hair back, that's fine. Just so it doesn't get in the water, I guess. Okay, I'm going to quickly get a paper towel. Okay, so I have my paper towel here. This is going to be my stationary phase. See me?
And I think I did something where like I take a paper towel and 2 cups and one of the cups has water in them and then another one doesn't, and then I put like one end of the towel in the cup with the water and the cup with the water and the other end in the cup without water, and like the water will travel from one cup to the other one.
Yeah, so that's why we're using paper towel, because the water really seeps up into paper towel. Additionally, I think coffee filters work. I wouldn't recommend using straight paper, although with the picture, I don't know, was it in like an index card? I really recommend using paper towels because that's what works best. So, don't do this now, but I have a little bit of water in my glass, just about that much. Even less would be fine. I just wanted to make sure I had enough. And what I'm going to do is I'm going to measure from the bottom of the water, not the bottom of the glass, because see, there's like this is where the water begins. This is where the water is, this is where the glass is. So I'm going to take my paper towel and I'm going to be like, I'm going to try to do this as best I can. I'm going to line it up with the bottom of the water, and then I'm going to hold it straight up like this. and see where the rim of the glass is, and I'm going to try and cut about 1/4 of an inch to 1/2 of an inch above there. So I'm gonna make like a fold here. So this is where the glass ends, and I'm gonna cut like here to leave a little bit of space. I'll make an indentation there, and you're gonna cut a strip about 1/2 an inch wide. It doesn't have to be exact, just not too thick or too thin. Let me cut this. And be careful with the scissors as well. Don't hurt yourself. Okay. All right, so I have a strip of paper. It's like about that much. I made it a little bit thin because I'm going to use multiple, but if you're only using one or two, one like pen, you can make it thicker. And I'm going to take my pencil and this pencil is going to serve as my paper holder. So on my paper, I'm going to take my Sharpie and I'm just going to draw a line about like 1/2 an inch to 1 inch up from the bottom. Let me do that. And make sure I'm really getting the pigment on there. Like this. And then I'm going to tape the top of that paper strip. And I'm holding my pencil horizontally, and I'm just gonna tape it onto this pencil on like the middle, sort of. Doesn't have to be exact, good enough. And make sure that is very tight, okay? And I'm gonna put my pencil and I'm gonna stick it into my water glass so that the tip touches bottom. And I don't know if this Sharpie works with chromatography. Okay, this Sharpie. If that happens, just put it back in the water. Yes. So this Sharpie does not, I think this Sharpie's alcohol based, but this one obviously is not doing it yet. So I'm actually going to do a top of it. But okay, I'm gonna write the materials on the screen while that is happening. All right, you will need 1 tall water glass, 1 pencil, 1 paper towel, scissors, tape, and 1 to 2 black pens or colored markers. I didn't put black markers. I think markers work best with this. And I believe that's all.
What about water?
Yeah, you need to have water in the water glass, but like, I think that's a given. Just make sure you have like a little bit of water in there. Yes.
I go get them now.
Yes, you guys can go get your things. Go, go, go. Go, go.
About how much water should we put in?
I would say like a quarter to about a quarter inch. So just about like one finger, kind of that much into the glass.
So what do we do after we tape the pencil to the paper?
So if you tape the pencil to the paper, you just lower the paper into the glass, and the pencil has to kind of like be set on the rim like this.
Do we have to use Sharpies?
You don't have to use Sharpies.
Okay,
In
because
fact,
like
some Sharpies don't, like this Sharpie, it's not working for some reason.
I
It
got
depends on,
I got some random marker that I found is the water's turning purple.
if the water is turning purple, is it traveling up the paper towel?
Not really.
Can I see like the setup that you have?
Oh, I just dropped the paper into the can.
Oh dear.
Can I use a green highlighter?
This thing, I need to fish the
Um,
paper out.
Oh, that should not happen. Was the pigment like above the water, like the pigment line above the water or below the water?
I don't know.
Um, yeah, I think that might be like mine is a little bit purple, but I think that's just because um it was a very I put a lot of pigment in, but it should not be that dark purple. I would say just rinse out your can, and if you want to, you can try again. Oh, and a word of caution, everybody, once the water reaches like the top of the paper towel strip, take it out of the water. And what you want to do is you want to take the tape and let it kind of dry a little bit on like a countertop. Alternatively, you can use like a disposable plate, which is what I'm going to go get in just a minute.
Wait, so where do we do the pigment line?
So you want to take the paper strip and you're going to try to put it above the where the water line would be, so probably like an inch or half an inch.
Okay.
I'd say an inch to be safe, like an inch above the bottom of the paper strip.
So basically it lets the paper soak and then pass to the black.
Yes, so you want the water to travel up and then meet the line and separate that pigment. And I'm gonna see if I can find a good black pigment to show you guys. Okay, this might work. Okay, and can everybody give me like a thumbs up on Zoom when you're finished with your chromatography? Hi Jaden. We're just doing a chromatography lab. Unfortunately, I don't know if you'll be able to do this in time because we've already been at it for a couple of minutes now. But basically we're just separating the mixtures of pigments. And this is what mine look like. I did one earlier and that looks like this. So you can see like at the top of the purple, there's more blue and here there's more orangish.
Mine just stopped when it got to a certain point.
Yeah, it should do that because there's just not enough pigment. Once it does that, you can take it out of the water. Like here, it didn't go all the way up. It didn't go all the way up here. So, and it shouldn't do that.
How far should it go up?
Depending on the pigment, probably at least like 60% up the strip or like 4 or 5 inches. Sometimes,
It went up like a third.
oh, that's okay. As long as it does go up a little bit, it doesn't really matter how far it is, as long as it is like separating. Just like some, um, like some inks aren't soluble in water, and that's the reason why it might not work. Like for example, earlier when I tried to do it, the line just remained there and it wouldn't separate because I think it's an alcohol-based marker instead of a water-based marker. Whereas like my coloring like brush pens are water-based.
I tried two kinds of markers. I think one of them works better than the other one.
Yeah, that's okay.
Because like one of them, there's a dot at the bottom where the ink is, and then like it's just like really light blue.
Yeah. Yeah. But yeah, I will fiddle around once with like different markers and see if I can get a good black marker. we'll see. Okay. Has everybody who wants to do the chromatography lab gone to that? Or is there anybody still working? Because I do want us to open cameras and show some results. If you do. For example, like I did another pink pen and it looks like this. It's much lighter, and it's not dried yet. But at the top, there's more blue. And same thing with the purple one I tried. This one's much more noticeable. You can see like it's darker at the top here rather than here. So those are two different pigments that are coming out. And again, with this one, there's more orange.
Can I show you what my black looks like?
Yeah. That's really good. What marker did you use for that one?
It's like we put them in this bin, kind of.
I see.
I'll take one of them out.
Oh my.
Like there's a lot of them.
Mhm.
I think the one I used was this.
Okay. If anybody else has done their chromatography and wants to share it, please go ahead. I'm really interested. I want to see which ones worked and which ones didn't.
I sent a picture in the chat.
Okay.
Yeah.
Oh, nice. So the green kind of yeah, look, wow.
And I also did one with like a purple color. And then another one was a blue color. The purple one's like this. It's just like you can't really see it. And then the blue one's like
Nora, did you have a question?
No, I don't know. It turned like it was like black at the bottom, but really purple up top.
Yeah. So that's like the different separations of the mixtures. So it would probably be like one purplish ink and one darker ink. Most blacks are actually just a really dark blue. So okay. Next filmmakers using that way. Oh dear. I'm sure I can find some kind of black. Yeah, Nora?
Wait, I forgot the word.
Oh, okay. Okay, since it seems like most of us are done with our chromatography, I'm going to move on to the next part, which is just reviewing the final course project. Remember, it's due next Thursday at the end of the day, and the assignment is to create an analysis of the evidence presented to your benefactor, and you have to answer the three big questions: who orchestrated the abduction of Ivy? Why was she abducted? And who do you think should be punished for her abduction? And you also have to make it clear and concise, only include pertinent evidence, connect your evidence to your claim, and it's easy understood. I'm gonna pull up the rubric. Classroom. Okay, so this is everything, and here are the instructions. So this is your rubric, which you will be graded on. It's 20 points, so not too big. And obviously it's not like a school assignment, but I hope you guys will have some fun doing it. And remember, you can use any format. So you can use like Google Docs, you can use Google Slides, you can make a poster and send a picture of it, whatever you think will be best
Also,
for sharing.
did you add more information?
Not yet. So the evidence will be all released this week, and next week will be mostly just work time for your course project. So yes, and make sure you're doing your evidence synthesis document as well. That is part of your course project. Okay, so I'm going to put on some.
I think this is the second to last time we're gonna be doing it.
Yeah, so next week is going to be
Like-
the last week. And the assignment is due next week at the end of the day. So I'll give you class time next week to work on it, and it should be submitted probably before the end of class, before we do a review game and a wrap up. Okay, so I'm gonna give you some guys
And
some
I
time.
think I just got like results from my green one, kind of. It's like it's blurry, kind of sometimes.
Okay,
Oh,
cool. All right, so I'm gonna give you guys time to work on that. Please make sure you're doing it, and I'm going to share some music.
and my water one, my yellow one's also done. But like some of these are dripping onto my computer.
Oh, and make sure you're drying them on like a disposable plate or something, so it's not dripping water. Yeah.
It's like if I hold it up, then it just like to the computer screen, it just drips on my computer a little.
Yeah, maybe don't do that. Just put it on like a disposable plate or something. Okay, so you guys have the rest of class time to work on this, and I'm gonna put on some music for you guys.